Hi guys, welcome to our second computer lab session for EF3450. This week we're going to use capital asset pricing model as an example to run simple regression and hypothesis testing using R. Before we start, I would like to apologize. I made some mistakes on the hypothesis testing part in the actual lab session, so I would like to take this chance to correct the mistakes I made. So let's begin. Just to brush up the theory side, we're going to run the regression of excess return of the risky security on the excess return of the market returns. So in other words, like excess return as the return minus the risk-free rate. But the files we have, the CSV file we have is capm_dataset_3.csv, consists the average monthly price of the risky asset and the market index. So in other words, we have to transform the price of these two data into returns, just like last exercise we did. And we also have a 3-month T-bill, which is the risk-free rate. Yeah, so let's start. So we'll first load the data into R and have a look on these structures. Before we further proceed, as I have something on the environment, let's clean it first. Now we clean the host and then we set the working directory. Again, like you're using your own account, so please change your working directory accordingly. And then we use read.csv function to load the data into R, and then let's display the structure. And as like last time, we see that dates is read as character, so we are going to use the transform function and s.date to transform the value and store it into date column again. And according to a month, day, and then year, like we search for the corresponding specifications. So since it's 4-digit, we use percentage capital Y, and then yeah, if things are different, like with different format, then you will need to adjust it accordingly, like by reading the documentation for stir time. Okay, let's run the command and then display the structure again, and we see that date column is now read in the correct format. Okay, and second of all, we have to compute the. We have to prepare a data frame of return so that we can run the regression later on, right? So we'll start by creating a new data frame, and this time we're not going to borrow the name from the price. We're going to create a character factor, which has more meaningful, like it's R to represent return, right? So it's an element of 2. You can see that even in here, and then we'll just create an empty data frame using matrix function, and then I convert back to data frame. And then we are going to insert first column using date from the data frame of data_x2, which is the price. Like we exclude the first row, the first dates, because like after differencing, we're going to use the second date. Yeah. And then the column names can be used to set or get the column names. If we assign value, then it set the column names, and if we just use column names, then we actually retrieve it. Yeah, you can see that like it is a character factor. And if you check the return data frame, we can see that like we have the dates on there, but the other thing is still NA, right? So we use sapply function and provide the same enormous function like last lab exercise again. and then we see that like the return is compute. If you're not feeling safe about this, you can do some naive checking, like let's use the first return and last return as an example. So like you can see that like the first two row of the price of IBM, and then the return of the IBM here, like we can see that if it's equal to each other, yes, and then same for the last return of IBM. Yeah, so basically we create the returns of the IBM and SP500. One thing I forgot, like, is the risk-free rate, right? The risk-free rate, we don't need to transform it because it's already the risk-free rate, right? We don't need to compute the change of risk-free rate. We simply use it directly. And again, like we exclude the first row because after differencing for the returns, the first observation is dropped. So, and if you check the data frame again, then now we have the return, the risk-free rate in the data frame as well. So let's pause for a moment. Oh wait, sorry. Like, it's optional. You can simply run the regression like this later on, but for if it is more convenient to generate the excess return explicitly. So it's based, you can, yeah. In that case, this data frame will consist everything you need for before running the regression.